Hello everyone, I'm Dr. Q. Welcome to my channel. In this video, we will identify the conditions under which a firm operates as perfectly competitive, monopolistically competitive, or monopoly. We will have a review of the rules for profit maximization for each of these market structures. We'll study monopolistic computation, that is, a unique market structure that combines monopoly and perfect computation. This table summarizes the characteristics of the four basic market structures. Please pause and read through. All right, the first market structure is pure computation. It's also called perfect computation. Pure computation and perfect computation are exchangeable. There are a very large number of firms producing standardized products. An example is unroasted or green coffee beans. About over 2.25 billion cups of coffee are consumed in the world daily. There are 25 million small producers who rely on coffee for a living in developing countries, producing green coffee beans to satisfy consumers worldwide. The unroasted green coffee beans are standardized products. There are two types of coffee beans, Robusta and Arabica. It is the brewers that differentiate the coffee beans into different flavors and take the largest margin. Unroasted or green coffee beans comprise one of the most traded agricultural commodities in the world. The commodity is traded in futures contracts on many exchanges, including the New York Board of Trade, New York Mercantile Exchange, and the New York Intercontinental Exchange. The coffee bean farmers have no control over the price of coffee beans. They must take whatever price the international traders offer them. The coffee bean farming industry is labor-intensive. One does not need much overhead investment or training to enter. There is no technology patent or any other barriers to prevent one from entering or exiting the industry. The coffee bean farmers work very hard on farming and have no resource to initiate any non-price competition such as advertisement or product differentiation. The second type is monopoly. We learned that there is a high barrier to entry due to economies of scale or technology patent or government contract or control over key economic resource. There's only one firm in the industry, such as Duke Energy in the North Carolina area for electricity generation, or EpiPen for epinephrine autoinjectors. The products are unique and have no close substitutes. Consumers have to purchase from the monopolist for the products. The only other option is do not purchase. Monopolists promote brand awareness such as advertising. They work on public relations. The third one is oligopoly. Oli means three. Oligopoly refers to a countable few. The products can be standardized or differentiated. If there are two firms in the industry, it is called a duopoly. Duopoly model is usually used to learn oligopoly market structure for the convenience of illustration. As there are just a few firms in the industry, it's easy for them to conduct tacit collusion, such as secretly agreeing on the elevated price, splitting the market. Those behaviors are usually illegal in the US due to antitrust law. It does not mean that the oligopolists won't try. An example is the US airline market, especially among the legacy airlines, Delta, United, and American Airlines. They share some flight markets. They normally accommodate among one another as opposed to erect barriers to entry or conduct predatory pricing against one another for fear of retaliation on other routes. Other examples in oligopoly will be the telecom industry, mass media, pharmaceuticals, soft drink industry, auto industry. There are significant obstacles to entry. The ability to influence price depends on their relationship with their rival firms. If the oligopolies compete, the price can be brought to a relatively low level. If they coordinate, they have a larger power in influencing price. If the oligopolist is involved in a correlation or cooperative arrangement with the purpose of maintaining prices at a high level and restricting competition, then it is called cartel. An example of coordinated oligopolies is OPEC, the Organization of the Petroleum Exporting Countries, who have control over price, production, and distribution of petroleum oil. It's hard to find a cartel example in any other industry in the US, but the athlete association, such as the NCAA, the National Collegiate Athletic Association, who control the contracts of athletes, stadiums, etc. There is a paper about why it exists, how it works, and what it does. I will attach in the end of this video. The last one is monopolistic competition. The number of firms are in between the one for perfect competition and the number for oligopoly. There are many firms producing differentiated products. The monopolistic competition firms have some, but not much control over price. It's relatively easy to enter or exit a monopolistic competition market. Firms try their best to differentiate their products, find their niche among the consumers. The firms within monopolistic competition do a lot of advertisements to promote awareness of the brand and how unique the product is. Restaurants that serve different types of food, clothing stores that sell different styles, or craft beer brands, hair salons, household items are examples of monopolistic competition. Please note that the universal rule for profit maximization for any firm across the market structure is marginal revenue equals marginal cost. And for the perfect competition firm in the short term, the price defined by the market is the demand curve faced by one firm. This firm can sell as many or as few of the products it can produce at the price defined by the market. Therefore, for each extra unit of product it sells, the revenue it brought in is the price of the product. Therefore, for and only for perfect competition firm, price equals the marginal revenue. We can also get the same conclusion from the total revenue and total cost curve. When the two of them cross each other, they're at break-even point. The firm is earning zero economic profit, and the slope of total revenue curve is marginal revenue. We take derivatives of total revenue with respect to the quantity and got marginal revenue. It is the coefficient in front of quantity, which is price. Therefore, the slope of total revenue does not change. However, the slope of marginal costs always change. We need to find the point where its slope happens to be equal to the slope of marginal revenue. We can see that among all the little bitty lines we draw along the marginal cost curve, this one is parallel to the revenue line. The firm is supposed to produce at this output level to maximize the profit, which is a gap between the revenue and the costs. Because for perfect competition firm, price is marginal revenue, and because marginal revenue must equal marginal cost to maximize profit, then a perfect competitive firm must produce the output at which price equals marginal cost in a range over which marginal cost is increasing to maximize profit. Here's a practice. Please pause and try. All right. This question asks what price the firm in a perfectly competitive market should charge for its products. Obviously, it should charge whatever the other firms charge, which is $20, the market price. If it charges more than that, it will lose all consumers to rival firms because there are so many firms producing homogeneous products. Next question. It asks the optimal output that maximizes profits. Again, please pause and try. All right. We need to figure out the marginal cost. Make it equal to price. So we take a derivative of a total cost function with respect to output Q. We got the marginal cost, that is 2Q. Equating price and the marginal cost yields 20. Price equals 2Q. Output is 10 units. Lastly, this question asks you what is a profit when it is maximized. Please pause and try. All right, the profit is the difference between total revenue and total cost. For total revenue, each product the firm sells, it collects $20 and it sells 10 units, so the total revenue is $200. For total cost, we plug the output 10 into total cost function. We got 105. Then the difference is the profit, $95. Now, let's review the monopolist profit maximization problem. Please note that monopolist itself faces the whole market demand curve, which is downward sloping. Monopolists can influence the price of products by changing their output level. For example, make the product scarce, and consumers are willing to pay a higher price, or make the products abundant and consumers pay for a lower price. Monopolies have big but not complete control over the price. The monopoly's power is constrained by the demand curve. It can choose price or quantity, but not both. The other one need to be decided by consumers on demand curve. Here's a relationship between monopoly's marginal revenue and price. Marginal revenue equals price multiplies this fraction. The numerator is 1 plus price elasticity of demand coefficient. Please note that elasticity of demand coefficient is always negative because of law of demand. So if the elasticity is smaller than the -1, such as -2 or -3.5 or -5, -6, then 1 plus elasticity coefficient is negative. So 1 plus -2 will be -1, right? So that will be negative. The denominator is demand elasticity and it is negative. So negative, negative, the fraction is positive. Therefore, marginal revenue is positive. If the demand is of unielastic, the numerator is 0. The marginal revenue is 0. If elasticity is in between 0 and -1, such as -0.2 or -0.6, then the numerator is positive, denominator is negative. Then the whole thing is negative, marginal revenue is negative, smaller than 0. Now, if we have a linear demand curve, which means the slope is a constant number, for example, the inverse demand function writes as price equal to intercept A, which is positive, plus B multiplies quantity. B is negative because of law of demand. Then its marginal revenue function will share the same vertical intercept A. The slope is twice as big as the inverse demand function. So here's a B, and marginal revenue will be 2B. To see this, we can write the functional form of total revenue, which is the product of price and quantity. We rewrite price with its quantity functional format. Plug A plus BQ over here, multiply Q, and we open up the parentheses. The total revenue function is AQ plus BQ squared. And take a derivative of total revenue with respect to quantity. We got the marginal revenue. AQ, take a derivative of that is A. BQ squared will move the 2 up front as coefficient, and original power 2 minus 1, it is 1, so 2BQ. You can go back to review the section of taking derivatives. Please note that the demand function is in its inverse form, which means price is on the left-hand side by itself and quantity is on the right-hand side. If we have a demand function, which means quantity on the left-hand side, we need to rearrange it to its inverse form. then figure out marginal revenue function. Here's a practice for monopolist. Please pause and try. All right, here's the answer. The first question asks you if the monopolist want to sell 3 units, what's the maximum price it can charge? Well, we plug these 3 into the demand function, right? So monopolists choose quantity, then consumers have to decide the price. For 3 units, the consumers are willing to pay 10 minus 2 multiplied 3, which is $4. Here's a second question and ask the marginal revenue. Pause and try. All right, according to what we learned for a linear inverse demand function, marginal revenue's intercept is the same, so it is 10. The slope is twice as big, so as opposed to 2q, minus 2q is minus 4q. Again, we plug 3 into this function. We got the marginal revenue equal to negative 2. And again, for any firm, the profit maximization output is where the marginal revenue equals marginal cost. For monopolist, total revenue increases at a decreasing rate before its maximum value. The total cost increases at an increasing rate. This is one of the marginal revenue line, and this is the one of the marginal cost lines. Monopolists should produce the output when the two of them are parallel to each other. The profit is maximized. We can see the difference between total revenue and total cost here at this point is the largest. Here's a practice for monopolist profit maximization. Please pause and try. All right, here's the answer. I want you to figure out the profit maximization point. So the first thing you need to write down is marginal revenue equals marginal cost. And we just did marginal revenue is written as this, 100 minus 4q. Marginal cost, we take a derivative of total cost with respect to quantity, it is 2. Equating the two of them, we got the output level to maximize profit, that is 24.5. Then we plug this into demand function to figure out price. 100 minus 2 multiplied 24.5, that is $51. Then for total profit, it is the difference between total revenue and total cost. Total revenue is again equal to price, 51, multiply the amount it sells, 24.5. Total cost, we plug 24.5 into the formula. Ten plus 2 multiply 24.5. The difference between the two of them is $1,190.50. Please note that there is no supply curve for monopolist. There is just a supply point, one particular pair of price and quantity that maximizes profit. And due to the market power of monopolists, they always charge a price that is larger than the marginal revenue equals marginal cost. This is graphical expression. So we find a point whenever marginal revenue equals marginal cost define the optimal output level. Since the monopolies define output, the consumers will decide the price. So we trace up to demand curve from this output level, figure out how much the consumers are willing to pay. So PM and QM is the point. And we can say this is the average total cost. And say at this output level, what is the average total cost or per unit cost? Again, we trace up to average total cost to figure out. Then the difference between price and average total cost is per unit profit. And multiply the units. So this rectangle area represents the profit. And for monopolist, it doesn't have a supply curve. It doesn't have a sequential of a price quantity combination. It only have one supply point. It will supply right at here. And monopolists can earn long run positive economic profit. Now, let's think about the situation that a monopolist produces output in different locations. It is a very practical situation. Then the manager must determine how much output to produce at each plant. Let's think about a simplified situation that a monopolist produces at 2 plants. The cost of producing Q1 units at plant 1 is cost Q1, and the cost of producing Q2 units at plant 2 is CQ2. When a monopolist produces a homogeneous product, it means that the products from the 2 plants are identical. Then the total amount of products is the sum of the two. Q1 plus Q2 is Q. According to demand function, consumers are willing to pay the price with respect to Q at the total output level. Let marginal revenue Q be the marginal revenue of producing a total of Q1. Q equals Q1 plus Q2 units of output. Suppose the marginal cost of producing Q1 units of output in plant 1 is marginal cost 1 with respect to Q1, and that of producing Q2 units in plant 2 is marginal cost 2 with respect to Q2. The profit maximization rule for the 2-plant monopolist is to allocate output among the 2 plants such that marginal revenue of total output Q equals marginal cost 1 with respect to Q1, and marginal revenue with respect to total output Q equals marginal cost 2 with respect to Q2. And why is that? Because the products are homogeneous. It means that they are the same to consumers. Consumers do not differentiate them. So the marginal revenue is based off the total output level Q, while the marginal cost is different across plants. with respect to the specific output level. Here's an example of figuring out the profit maximization output for each plant. Please pause and read through. It says, suppose the inverse demand for a monopolist product is given by price with respect to output equals 70, vertical intercept minus 0.5 total output Q. The monopolist can produce output in two plants. The marginal cost of producing in plant 1 is marginal cost 1 equals 3 multiplied Q1, and marginal cost 2 is Q2. How much output should be produced in each plant to maximize profits, and what price should be charged for the product? To maximize profits, we just learned that we need to follow this rule, which is marginal revenue with respect to the total output of the two plants equal to the marginal cost at each plant. In this instance, marginal revenue is given by 70 vertical intercept, 2 times of the slope. So 2 multiplied 0.5 will be 1, so minus Q. And Q is a summation of Q1 plus Q2. And substituting these values into the formula for the multi-plant output rule, we can say marginal revenue 70 minus Q1 minus Q2 equals marginal cost 1, 3Q1, marginal cost 2, Q2. So this is the first step you're supposed to do. And we rewrite this part. We focus on the first part, plant 1. Okay, just focus on the first equation. And 70 minus Q1 minus Q2 equals 3Q1. We rearrange it. We move this Q1 to the right-hand side. We can write as the following. That's the first equation we got. And if we focus on the second one, equals 70 minus Q1 plus Q2 equals Q2. And we can rearrange that, move the Q2 to the right-hand side. We can write 70 minus Q1 minus Q2. Q2 move to the right-hand side will be 2Q2. So that's our second equation. And we made these two equations. So move the Q2 to the right-hand side. It is Q2 plus 4Q1, that is 70. Move the Q1 to right-hand side. 2Q2 plus Q1 is also 70. So the two of them both 70 equal to each other. So we got this relationship. Q2, 2Q2. So we got the Q2 by itself on the right-hand side. Q1, 4Q1, we move this Q1 to left-hand side, we got 3Q1. So this is the relationship between the two of them. 3Q1 equals Q2. Okay. So we rewrite this marginal revenue. It's a 70 minus Q1 minus Q2. And we replace this Q2 with 3Q1. So it will be 70 minus 4Q1 over here. We make it equal to first marginal cost curve, which is 3Q1. So 70 minus 4Q1 equals 3Q1. We got 70 equals 7Q1. Q1 is supposed to be 10. Then marginal revenue, the 3Q1 equals Q2. So Q1 equals to a third of Q2. Then we write this marginal revenue, everything with Q2. So Q1 can be replaced by a third of Q2. So 70 minus 4 over 3 Q2 equals marginal cost of Q2, which is Q2. So 70 minus 4 over 3 Q2 equals Q2. And we move the negative to the right-hand side. We got 70 equals 7 over 3 Q2. Q2 is 30. Now, we got Q1 is 10, Q2 is 30. We can plug those numbers into the demand function and figure out corresponding price, which is $50. Did you figure out? Now, let's switch to the market structure of monopolistic competition. Here's a summary to review the characteristics of monopolistic competition. There are many buyers and sellers. Each firm in the industry produces a differentiated product. So the products is not homogeneous. They're not identical. Each brand or each type has its unique features. And there's a free entry into and exit from the industry. So they are producing differentiated products. So it is very similar to perfect competition market structure, but the products are differentiated. So products are close but not perfect substitutes. Therefore, each firm's demand curve is downward sloping under monopolistic competition. Also, products we use daily are from monopolistic competition markets, such as fast food restaurants, toothpaste, mouthwash, detergent, gasoline, aspirin, car wax, allergy medicine, cosmetic products, clothes industry, bottled water. To promote brand awareness and build up customers' loyalty, the monopolistic competition firms spend huge amounts of money on advertising campaigns. And all those commercials try to convince potential consumers that they are unique, special, and better than any other similar products. Every clothes brand has their style and targeted consumer pool. Restaurant like a Subway differentiates itself from other fast food chain stores in that their sandwiches are healthy. Sensodyne focuses on designing toothpaste for tooth sensitivity. Comparative advertising is common for monopolistic competition firms. If comparative advertising is effective, it will convince the loyal consumers to pay a premium for a particular brand. The additional value that a brand adds to the product is known as brand equity. Another approach often used by monopolistic competition firms is frequently introducing new products. Soft drink companies bring in new flavor or new packaging, special edition, collaboration, etc. And new products are often introduced to fill a special need in the market. It is called niche marketing, such as gluten-free food, green products that are made from recycled materials, detergent that is biodegradable, etc. Successful brand differentiation can bring a firm big profit, but also make managers myopic. A brand myopic manager is happy about the existing brand and slow on launching new products and makes a firm miss new opportunities or new potential market. For the optimal amount of money to be spent on advertisement to maximize profit for monopolistic competition firms, it depends on the nature of the industry. But after all, it is a marginal analysis question. The fundamental rule is marginal revenue equals marginal cost. The profit maximization advertising to sales revenue ratio is calculated as the numerator is the advertising elasticity of demand for the firm's product, and the denominator is the negative own price elasticity of demand for the firm's product. Because the own price elasticity of demand is negative, and negative is positive, so the whole ratio is positive, and it is profit maximization advertising to sales ratio. Please note that the negative inverse of own price elasticity of demand can be expressed as the price cost margin. Therefore, you can also figure out the profit maximization advertising sales ratio by this formula. Please note that the demand curve faced by one monopolistic competition firm is demand for that specific product. For example, Nestle Crunchy cereal. The demand is composed by consumers who like crunchy cereal and that flavor. Not all the consumers for all cereal consumption in general. So the demand and marginal revenue are the ones for the individual firm's product as opposed to the market. To maximize profits, a monopolistic competitive firm produces where its marginal revenue equals marginal cost. Of course, as monopolistic competition firms produce differentiated products, the industry market demand is sometimes not well defined. Here's a quick review of the profit maximization rule. The profit maximization output Q star is where marginal revenue equals marginal cost. The profit maximization price is the maximum price per unit that consumers are willing to pay for the profit maximization level of output. Here's a graphical expression. It should produce where marginal revenue equals marginal cost, traced down to output or quantity axis. We figure out optimal output, Q star, and we trace up to demand curve to figure out how much money the consumers are willing to pay, P star. And at this output level, what is my cost per unit cost? Average total cost. And again, its profit is represented by this rectangle area, quite similar to monopoly. This is a practice for monopolistic competition firm. Please pause and try. Alright, so we know price demand curve is in its inverse linear form. So marginal revenue share the same vertical intercept and the slope is twice as big, Marginal cost, we take derivative of that with respect to output. We got 2. Equating the two of them, we figure out quantity is 24.5. Plug this into the demand function, figure out the price. Again, profit is this number, just like the monopolists. Now, let's have a look at the long-run equilibrium of monopolistic competition. As there is a free entry into and exit from the industry is quite similar to the perfect competition one, except that the demand curve faced by monopolistic competition firm is downward sloping. If firms in monopolistic competitive markets earn short-run profits, additional firms will enter in the long run to capture some of those profits. Entry will increase supply and bring the price down and exhaust the profits. New firms will keep entering until economic profit is zero. On the other hand, if firms bear short-run losses, then some incumbents will exit the industry. Smaller number of firms will decrease market supply, increase price. Firms will keep exiting until economic profit is zero. Here's a graphical explanation. Assuming initially the monopolist competition firm in this industry earn economic profit, then new firms enter with their new brands or differentiated products for the profit and split the market and some of the consumers. Therefore, the demand faced by the firm decreases, and the marginal revenue decreases consequently. The entry will not stop until the new price on demand curve that is willing to be paid by consumers happen to be equal to the average total cost, which means economic profit is zero. When the downward sloping demand curve is tangent to the decreasing portion of average total cost curve, decreasing portion, tangent, monopolist competition achieves long-run equilibrium. It is stable. It has no intention to deviate from this point unless the market conditions change. Price is equal to corresponding average total cost. However, it is higher than minimum average total cost, also higher than its marginal cost. And in the long run, firms within monopolistic competition industry tend to earn zero economic profits. Here's a summary of the conclusion for monopolistic competition. Alright, that's all I have for this video. I'll see you in the next one.